Hello, this is Paul from Forza Tech. In this lecture, we are going to deal with the strategies for integration. We have 4-step strategy here summarized here. And the first step, when we look at the integral, so we need to think if it is simplified or not. Okay, if it's possible to simplify, we always simplify the first step. Okay, everyone knows this, right? The second, we look at it obvious substitution. Okay, the obvious substitution is the second step. If we can go to there. If substitution does not work, so we can try this. We can try to classify the integrand according to its form. Sometimes the integrand is a trig function. If it's a trig, remember we have a big topic called a trig integral, right? Or if the integrand is a rational functions, we definitely know to choose a partial fractions, right? Or so the integrand has some type we call the integration by parts part. Why? We did some experiment. Okay, some questions like the power, the product of power and exponential, or the product of power and the trig function, or the product of exponential function and the trig function. So these three basic type we did a lot of examples, right? Okay, if we made this, going to use the integration by parts. We set up u is the power, or here we have to go back a loop to solve the equation. Remember this? Okay, the another type, if the integrand is radical, means what? Radical is like square root or something, or nth root of something. Okay, so usually we have this method, rationalizing substitution. We substitute the whole radical first, and then we're going to a rational function. Then we use partial fractions. This is the basic type, right? Remember that. So, however, if the third step still does not work for us, so we have to try again and again. Don't fail. Okay, don't give up. So, like try what? We can try substitution, or we can try integration by parts, or even it's complicated. Sometimes we can manipulate the integrand. We have a lot of examples show to you how to manipulate the integrand to get simple, right? Or we can relate our problem to the previous problems. If the previous problem we have resolved something, the results definitely we can use. Or we just merge or combine all the several steps together. Okay, different type of method we combine together. So why we need this? Because sometimes the integral is very complicated. Okay, sometimes and a lot of times integral is very complicated, not as simple as just I should do some examples. I will show you 2 examples. This is not so complicated, but definitely we show the basic idea how to think about this 4 steps. Look at this. So what do we need to do? We just check, right? Follow. We're going to check one by one. Check the first step. Do you remember what the first step? See if we can simplify or not. We can simplify the integration or the integrand. No, it's already very simple, right? So we cannot go to the first. So the first step failed. We're going to the second step. Do you remember? Is looking for an obvious substitution. Okay, so I simply say is obvious substitution. Do you think this work? This time definitely. Can you see this term? Yes. So what kind of substitution? We substitute that this is u, because later I will going to use the variable u again. So I substitute this square root of x as t. Okay. So I will do this substitution. I will substitute the t equals square root of x. Okay, and after the substitute, we're going to see that this integrand will get simple. Why? Because we're going to step by step. So we need the dx, right? Resolve x first. Square both sides, get x equal to t squared. And then take a derivative of dx, we know is 2t dt. Okay, so this we need to do the substitution. Then what do we have? I will put this to here. Okay, suppose we do this this t, right? So the integrand goes to et, and then dx goes to here, our time 2t dt. Okay, it's good. This is much simpler than that. Why? Because we don't have a square root. Okay, so now probably you can think what this type. Okay, this is a type of integration by parts. Why? This is a power, right? It's a power function. This is exponential. The product of the power and the exponential, do you remember? Okay, so, and usually we set it up, this is u, this is dv. So basically we are having to do this. I switch the order. Okay, I switch the order because this you know is already integration, you know, is integration by parts. Okay, the type. Why? Because this is a power times exponential, right? This is the product of this, and it is usually we're going to use the integration by parts. Okay, and then look at it. If I switch, what do I get? Of course, 2 I will pick out, so, and factor out, and then t goes here, and then et goes here, and then dt. Okay, you know how to set up, right? And these are set up as u, so this big term is set up as dv. I mean we need to set up in this. I mean u equals t, so dv equals et dt, and then easy, right? So easy to resolve what is du. Du is dt, and then v is what? And that divided with this is e raised to is the self, right? Okay, we do need this for the parts, the integration by parts. So now what do I have? Integration by parts, you remember? So 2 is there 2. I put the big parenthesis. I put a big parenthesis. Here is u times v, right? Where's u? T. Where's v? Et. And then minus to integration v. Et. du, which is dt, right? Okay, so this is the integration by parts. Now this is a function, and this we know the entire derivative. That means we know everything. Okay, so I put it here now. Is 2 parenthesis t et. What is the entire derivative? At the self, right? Okay, down. Here we don't need the plus c because we have c there, right? So, but here we do need the plus c. Okay, and the last step, go back substitute, right? We need to what? Back substitute. So after substitute, what do I get? I get this. T is square root of x. E square root of x minus e is the power square root of x, and then plus c. Okay, so this example is just follow this step, 4 steps. Okay, the first step failed, the second step works. Let me show you one more example here. Can we see? So the same. Okay, so this integrand looks complicated. I was still going to check. The first step, can we simplify the integral? This looks complicated. Probably we can. Do you remember which method to simplify this? Yeah, we do. What type of method? Rationalize the denominator. Do you remember this? Rationalize the denominator. Do you remember that? Denominator. Yes, we do learn the basic. Okay, it's in the basic algebra. Okay, in basic algebra we know. If I put there, so see the first step works, right? And this time I will go into this. How do you simplify? How do you rationalize the denominator? So you remember how to do? Is times the conjugate, right? Times the conjugate of denominator, which is x plus 1 plus square root of x, okay? And the time this to the bottom, you have the time the same to the top. See, this fraction is 1. Times 1, we never change anything. Okay, this is called the rationalize the denominator. Can you see? By this way, we can rationalize. When you say this gets complicated, but don't worry. Okay, so we're going to do calculation. I will get all this integral. Do calculation here. Can we see? The top is the same, right? No change. What is the bottom? And the a minus b, a plus b, the difference times the sum is the difference of square. Remember that? The difference of square. So the first square minus the second square. Okay, you see, now it's much simple. So there is x plus 1 plus square root of x. The bottom we go to x plus 1 minus x. Can you see? This x and this x we can cancel, right? The bottom goes 1. Now this is the only left. The only functions we left is this. Now parentheses square root of x plus 1 plus square root of x dx. Okay, now you know what is. Okay, we look at this integral. This is much simpler than that. Why? Because we don't have a denominator. Okay, and this is much simple, right? Okay, much simple than before. See, this is why we said that we can simplify. Of course, now we think, can we get the antiderivative? Definitely. This is what? Power function. This is already goes to power function. Everyone know power function is the easiest, okay, in the integration. Okay, so what are we going to? I'll write this as in power, as the form of power. So the first is x plus 1 raised to the 1/2 power. The second is x raised to 1/2 power, and the dx. See, this one is power. Both of them are power, right? So what are we going to do? Directly find the antiderivative. This is what? Is a power raised to the power plus 1. Okay. So is 2/3 x plus 1 raised to the 3/2. Okay. Here is the similar 2/3 x raised to the power of 3/2. You take this as a divisor, you could definitely get that. Don't miss plus c. Can you see? Okay, so this is the basic strategy. That's all. Thank you.